Thank you for viewing this Algebra 1 FSA EOC virtual review session. I hope that you will be able to glean some good information from this session. During this review session, I will give you an overview of the test, review some content, give you some test-taking tips, and show you where to find resources for the FSA. Now, let's take a look at the test in general. The Algebra 1 FSA consists of two 90-minute sessions. The first session, taken on day 1, is a non-calculator session. The second session, which is taken on day 2, is a calculator session. For each session, you must sit for a minimum of 90 minutes. But don't worry if you don't finish during this time frame. You can get an additional block of time if you need it. The questions for the assessment are broken up into 3 reporting categories. These categories are Algebra and Modeling, Functions and Modeling, and Statistics in the Number System. Some of the item types you may see on the assessment will include editing task items, which means you edit a response, grid items, where you're placing points on a coordinate plane, hot text items, where you're typing in your answer, multiple choice items, where you're selecting one answer from the choices given, multi-select items, also known as select all that apply, where the selection of answers is not limited to one, open response items, where you will type in your answer or justification, and equation items, where you will use the equation editor tool to type in your equations. For the FSA, you will be using an online scientific calculator powered by Desmos. You may practice using this calculator at desmos.com or on the fsassessments.org site. This calculator can be downloaded on both Android and Apple phones, but be aware you are not allowed to use cell phones in the testing area. By downloading this app, you're using it for practice only. If you're using a handheld calculator, only certain types of calculators are allowed. You can find this information at fsassessments.org, or your school will give you the information. Now let's go over some content. I've picked some different types of questions that I've seen on the assessments that you have taken throughout the year and thought that these questions needed to be reviewed. The questions are what we called the most missed questions based on the data from the section, mid-year, and mock assessments that you've taken. The first category that we're going to review is the Algebra and Modeling category. 41% of the questions you will see on the FSA come from this category. So we're going to start off with a word problem. Now with word problems, you need to make sure and read them completely before you get started working on them. Then you can go back and highlight or underline key information in the problem. So Carlita has a swimming pool in her backyard that is a rectangle with a length of 24 feet and a width of 14 feet. She wants to install a concrete walkway of width C around the pool. Surrounding the walkway, she wants to have a wood deck that extends W feet on all sides. Find an equation for the perimeter P of the wood deck. So now we're going to go back in and pick out the key information. So Carlita has a swimming pool in her backyard that's a rectangle. The length of this rectangle is 24 feet and her width is 14 feet. So let's talk about perimeter for just a minute. With perimeter means that you need to walk the boundary line of the pool. So we will walk here, all the way around. So when we do that, we have walked twice the length and twice the width. All right, now let's see. She's going to put a walkway of width C around this pool. So here it comes. So now let's find our perimeter with the concrete. When we do this, we have to be careful because our length is now going to be the original length plus these two C's. times 2 because there's a top and a bottom to the pool. when we find the width, we're going to have to include these two c's again on this side. And there'll be a right and a left to the pool, so it's going to be times 2. So it's a little tricky. If we don't include these c's, then we're going to have a hole in our concrete. So our equation now for the perimeter will be 2 times the 24, the original length, plus our 2 c's on each end, plus 2 times the width of 14, which is the original width, plus the 2 c's for our concrete. All right, back to the problem. Let's see what she wants to do now. She wants to have a wood deck that extends W feet on all sides. So let's see what that looks like. Okay, so we're going to find our width now with not just the concrete, but also with the wood. So again, be careful. You've got your original length plus the 2 c's, plus now we have 2 w's. Okay, so our perimeter for the length will be twice the length plus 2 c's plus 2 w's, and the width will be the original width plus the 2 c's plus 2 w's, but remember there's a right and a left side to this pool, so we're going to multiply that by 2. So now let's see what our perimeter looks like when we do distributive property. So 2 times the 24 plus 2 times 2c plus 2 times 2w, which takes care of our length, plus 2 times 14 plus 2 times c plus 2 times 2w to take care of our width. That gives us 48 plus 4c plus 4w plus 28 plus 4c plus 4w. Goodness, that's a lot. So let's combine our like terms and see what we have. Our perimeter will be 76 plus 8c plus 8w, which is answer choice D. Mina's catering service is organizing a formal dinner for 280 people. The hall has 2 kinds of tables, one that seats 4 people and one that seats 10 people. The hall can contain up to a total of 52 tables. Let X represent the number of 4-seat tables and Y the number of 10-seat tables. Write a system of inequalities that can be used to determine the possible combinations of tables that can be used for the event so there are enough seats for all the people. Now we're going to go back in and highlight the important information. You have a table X and a table Y. Together, these 2 types of tables must be less than or equal to 52 tables. The room cannot hold any more than 52 tables, so our maximum is 52, and we will use the inequality sign less than or equal to. So this will be our answer choice A. Now let's determine the inequality to find the number of people. For table X, this table seats 4, and table Y seats 10. Together, this combination of tables will seat less than or equal to 280 people. There is only 280 people that can attend this dinner, so that's our maximum. Again, we're using the less than or equal to sign. So our answer choice for this system will be letter C. For the second part of this question, we need to determine which points are possible solutions to the system that we identified. In other words, which points make the inequalities true at the same time. Testing answer choice A, 20 plus 15, which equals 35, is less than 52, so this point is true for the first inequality, but we have to test the point with the second inequality. Substituting in 20 for X and 15 for Y, we find that 4 times 20 is 80, 10 times 15 is 150, Since 80 plus 150 is 230, which is less than the maximum of 280, this point makes the second inequality true, therefore we can select answer choice A. Now let's test answer choice B. Substituting in a 35 for x and a 20 for y into the first system determines that this point is not valid because 35 plus 20 is 55, which is more than the allowable 52 tables. You can test the point with the second inequality, but since the first inequality is false, it's not necessary. Should you decide to test the point, in the second inequality, you would find that 4 times 35, which is 140, plus 10 times 20, which is 200, would be 340, which is more than the maximum of 280, so the point makes the inequality false. Testing answer choice C, substituting in 15 for x and a 20 for y, 15 plus 20 is less than 52, so this point makes the first inequality true. Substituting this point into the second inequality, we have 4 times 15 plus 10 times 20 is 260, which is less than our 280, so this point makes both inequalities true at the same time, so we can select answer choice C. Testing answer choice D, 20 plus 35 is more than the 52 tables, so the point makes the inequality a false statement. Therefore, we will not select this point. Now I'm going to extend this problem. If we had been asked to choose all the points that are possible solutions based on the graph of the real-world problem, we would see these inequalities graphed on this slide. Each of the inequalities would be graphed with solid lines, since the inequality symbol is less than or equal to. If the inequality had been just less than, we would be using a dashed line. The solution area is the set of points that make all the inequalities true. That means this area right here, which is the combined shaded areas of the pink and the blue. So now let's test our points. Point A is in the combined shaded area, so this point makes the inequalities true at the same time. So we would select point A, which we have already done. Point B is not in the combined shaded areas, so we would not select this point. Point C is on the boundary line and in the combined shaded areas, so we will select this point since it makes this inequality system true. Point D is not in the combined shaded areas, although it is on a boundary line, but since it's not in the combined shaded areas, it does not make the inequality system true, therefore we will not select this point. Eric has been tasked with transforming the quadratic equation 3x squared plus 36x plus 88 equals 4 to vertex form. Determine what steps Eric will need to take to convert the quadratic equation to vertex form using the completing the square method, then drag the appropriate values into the correct empty box below. So Eric is going to use the completing the square method to change 3x squared plus 36x plus 88 equals 4 from standard form to vertex form. First, Eric will want to subtract 88 from both sides of the equation. This will isolate the variables to the left side of the equation and the constants to the right side of the equation. When he subtracts the 88 from both sides of the equation, he will get 3x squared plus 36x equals negative 84. Next, Eric will want to divide by the coefficient in front of x squared, the a value. When he does this, he'll want to divide all terms by 3. This will simplify his quadratic equation to be x squared plus 12x equals negative 28. For completing the square, Eric will want to insert a blank on both sides of the equation. in this blank, he will be substituting the value of b divided by 2, then squaring that value. So our b value is 12. We'll take the 12, we'll divide it by 2, which will give us 6. We'll square that value, which will be 36. And he'll insert the 36 on both sides of the equation. Next, Eric will factor the left side of the equation and combine the like terms on the right side of the equation. When he factors the x squared plus 12x plus 36, he will get x plus 6 squared. When he combines the 36 and negative 28, he will get 8. So he will drag the 6 into the first box and the 8 into the second box to complete his answer. For this question, we're going to solve 8x squared equals 135. Then we're going to select all the answer choices that apply. So to start off, here's our 8x squared equals 135. If this question is on the calculator section of the test, you're going to want to solve for x by dividing both sides of the equation by 8. Then we'll have x squared equals 16.875. Now you're going to take the square root of both sides of the equation. When you do this on your calculator display, you will see that x is 4.107919181. What you will not see is the negative value of this number, so you'll need to remember that when you take the square root of a number, you have a positive and a negative value. Why? Because positive numbers times another positive number equals a positive number, but also a negative number times a negative number could also give a positive number. Since answer choices C and D are not the rounded value of 4.1079 or negative 4.1079, we can eliminate these answer choices. On the FSA, you will want to use the Eliminator tool to cross out answer choices C and D. So now we will need to solve the quadratic equation in radical form. We have our original equation, 8x squared equals 135. We will divide both sides of the equation by 8, then take the square root of both sides of the equation. You will have x equals plus or minus the square root of 135 divided by 8, or we can separate this fraction into two parts and simplify the square root of 135 in the numerator, then simplify the square root of 8 in the denominator. So let's start off with our numerator. We want to find the factors of 135, the perfect square factor. Now, if you don't know the perfect square factor of 135, you can use a factor tree. So when we divide by 3, we see that 3 times 45 is 135, and neither one of these factors is a perfect square. So we're going to see the factors of 45. 5 times 9. 9 is a perfect square, so we're going to rewrite our numerator to be 9 times 15. We'll take the square root of 9, and we'll be left with 3 times the square root of 15. Now let's simplify our denominator. We need the perfect square of 8, and if you can't remember what that is, you can use your factor tree again. You'll see that 2 times 4 is 8. 4 is a perfect square, so we're going to rewrite 8 as 4 times 2. Then we'll take the square root of 4, which is 2, and we'll leave the factor of 2 underneath the radical. Putting these together, we have that x equals 3 times the square root of 15 divided by 2 times the square root of 2. Well, we can eliminate answer choices B and E because if you look in their denominators, they both show 2 times the square root of 4, and our denominator is 2 times the square root of 2. So again, we're going to use the eliminator tool, and we're going to eliminate answer choices B and E. So now we've eliminated choices B, C, E, and F, so the correct answer choices should be A and D. But why does our answer of x equals plus or minus 3 times the square root of 15 divided by 2 times the square root of 2 not match answer choices A and D? Because we have one more step. We can never leave a square root in the denominator. We either have to take the square root of the number, or we must rationalize the denominator. In this case, we cannot take the square root of 2 and get a whole number, so we will rationalize the denominator. To do this, we will multiply both the numerator and the denominator by the square root of 2. Underneath our radicals, we will see in the numerator 3 times the square root of 15 times 2 and 2 times the square root of 2 times 2. We'll simplify this further, and we'll get x equals plus or minus 3 times the square root of 30 divided by 2 times the square root of 4, which we've seen before. And we'll take the square root of 4. So we'll get plus or minus 3 times the square root of 30 divided by 2 times 2, which now shows us that x equals plus or minus 3 times the square root of 30 divided by 4, which clearly is answer choices A and D. Our next set of problems will come from the functions and modeling category. Functions and modeling standards make up 40% of the FSA. So we're going to start off with the linear function. The cost to fill a car's tank with gas and get a car wash is a linear function. The costs of a fill-up and a car wash for 3 different customers are shown in the table. Write an equation for the function in slope-intercept form, then find the cost of a fill-up and a car wash for a customer with a truck whose tank size is 22 gallons. As you may recall, a linear function in slope-intercept form is f of x equals mx plus b. Since our problem is dependent on the gallons of gas, I'm going to substitute in a g for the f of x, and I'll get f of g equals mx plus b. Now I need to calculate the slope or the rate of change. Slope or the rate of change is the differences in our y values, delta y, divided by the differences in our x values, delta x. So using the table, I'm going to subtract $31.08 from $50.16, which will get me $19.08 in my numerator. Then I'm going to subtract 9 from 18 for my x values and get a value of 9, which will be in my denominator. When I divide this fraction, I will find that my slope is 2.12. So I'll put this into my equation. Next, I need to calculate the y-intercept for our function. To calculate our y-intercept, we're going to have to adjust our table of values to allow for 0 gallons of gas. So here's our table. For the y values, I will need to subtract 3 times $2.12 for 6.36, since our intervals are in a pattern going by threes. So $31.08 minus $6.36 will leave me with $24.72. For 3 gallons of gas, I will get $18.36 by subtracting $6.36 from $24.72. And for our y-intercept value, when I subtract $6.36 from $18.36, I get $12. So at 0 gallons of gas, which would be our y-intercept when x equals 0, my cost is $12. So I'll place this into my equation. Finally, I'm going to substitute 22 gallons into my equation to get the cost of 22 gallons of gas. So here we go. There's my equation. Substituting in the 22, I find that 22 gallons of gas is $58.64. A toy rocket is launched from the roof of a building. The height h in feet of the toy rocket, t seconds after its launch, can be modeled by the function h of t equals negative 16t squared plus 64t plus 20, with the rocket reaching its maximum height at 2 seconds. For the interval t equals 2 to t equals 4, complete the statement below. From the problem, we know that at 2 seconds, the rocket is reaching its maximum height. We are asked to look at the interval between t equals 2 and t equals 4. From the interval 2 to 4, we see that the rocket's height is decreasing. To find the average rate of speed, we can use the slope triangle, which has a rise of 64 feet, which we will divide by a run of 2 feet to get 32 feet per second. So our average rate of speed is 32 feet per second. If we were asked to find the maximum height, since we are given a time of 2 seconds for the rocket to reach its maximum height, we could substitute in a 2 into the equation. H of t equals negative 16t squared plus 64t plus 20. And we will find that our maximum height will be at 84 feet. From a height of 5 feet, a slingshot launches t-shirts at the crowd at a basketball game. The slingshot launches a t-shirt with the initial upward velocity of 64 feet per second. The t-shirt is caught 35 feet above the court. The function h of t equals negative 16t squared plus 64t plus 5 gives the t-shirt height h in feet after t seconds. Use the vertex formula to determine how long it takes the t-shirt to reach its maximum height, then find its height. So the problem is asking us to use the vertex formula to identify how long it takes the t-shirt to reach its maximum height and to find the height. To get started, we will need to identify a, b, and c of the quadratic equation. So a is negative 16, b is 64, and c is 5. The vertex formula is negative b, or the opposite of b, divided by 2a. We will substitute the values of b and a into the formula to get negative 64 divided by 2 times negative 16, which will give us 2. This means that the maximum height will be reached at 2 seconds. For the height, we will substitute the 2 seconds into the equation, which gives us a value of 69 feet. So the t-shirt will reach its maximum height of 69 feet after 2 seconds. The problem now wants us to find the range, which means that we need to find the minimum height. The minimum height is at x equals 0. So we will need to substitute a 0 in for the time which will be the start of the launch, or our y-intercept, to get our minimum height. We can find the y-intercept also by looking at the constant c in our equation. So, the height of the t-shirt at any time is between 5 and 69 feet. The range of the function will be between 5 and 69. So 5 is less than or equal to the height is less than or equal to 69. Consider the function h of x equals -3 times the quantity of x minus 4 times the quantity of x plus 2. So for part A, we want to find the x-intercepts. We will use the zero product property by setting the factors x minus 4 equal to 0 and x plus 2 equal to 0, then solve for x. So x equals 4 and x equals -2. For part B, to find the axis of symmetry, you will want to multiply the polynomial -3 times the quantity x minus 4 times the quantity x plus 2 out. By completing the multiplication, we will be able to answer part F and use the quadratic to find the axis of symmetry, the y-intercept, and the vertex. Now you have a choice when you're multiplying this polynomial. You can either multiply -3 by x minus 4 first using the distributive property and get a result of -3x plus 12, then multiply this polynomial by the quantity of x plus 2 and get -3x squared plus 6x plus 24, or you can multiply the quantity x minus 4 times x plus 2 first to get x squared minus 2x minus 8, then multiply that result by -3 to get -3x squared plus 6x plus 24. Whichever you choose, you're going to come out with the same answer. So our standard form of the equation will be -3x squared plus 6x plus 24. Some students prefer to use the box method for multiplying polynomials, which will give the same result. Again, it's your choice. We will still get -3x squared plus 6x plus 24. From the standard form of the quadratic, we can get a lot of information. One of the quickest pieces of information we can get is the y-intercept. The y-intercept is the constant of the quadratic equation. So our y-intercept is at 0, 24. The mathematics behind this is if I substitute in a 0 for the variable x, because our y-intercept is when x equals 0, and then solve, I would get an end answer of 24. Now we can find the axis of symmetry by using the equation -b divided by 2a, which means that we will need to identify our a and b terms from our quadratic equation. So the coefficient in front of the quadratic term will be our a value, so a equals -3, and the coefficient of our linear term, which will be our b value, so b will be 6. Substituting these values into the equation, -b, or the opposite of b, divided by 2a, we get -6 divided by 2 times -3 equals -6 divided by -6 equals 1. So our axis of symmetry is at x equals 1. To find the vertex of this quadratic equation, we can substitute our value of 1 from the axis of symmetry into the quadratic equation. Then we will solve, and we will get a value of 27. So our vertex will be at 1, 27. Now we can use the a value that we've already identified to be -3 to write our vertex form of the equation. Then we can use the x value and the y value of our vertex to complete the vertex form of our equation. So h of x equals -3 times x minus 1 squared plus 27. Now we're going to go over some problems from the statistics and the number system category. This category accounts for 19% of the FSA. So Eric is analyzing a data set, and you're given a table of values. For the line of fit, y equals 4x plus 10, what is the residual of the data point at x equals 3? For this problem, we will need to calculate the actual value of this data set and subtract it from the predicted value of the data. So we're going to look at the data at x equals 3, and our actual value at 3 will be 20. Next, we're going to use the line of fit to get our predicted value. So substituting in a 3 into 4x plus 10, we get 4 times 3 plus 10, so y will be 22. To find our residual value, we'll take our actual value of 20 and we'll subtract our predicted value of 22 to find out that our residual value is -2. For this problem, I need to find the mean, median, and interquartile range for the data set. My data set is 17, 23, 8, 5, 9, 16, 22, 11, 13, 15, 17, and 18. Now, to get started, I want to add up all the values of my data set, and we'll get a result of 174. I will take that result of 174 and I'm going to divide it by the number of values that I have in my data set, which was 12. So 174 divided by 12 will give me 14.5. So my mean will be 14.5. Next, I want to find out what my median is. To do this, I need to reorder my data set in numeric order. Since there are 12 values, I'm going to have to estimate or find the average of the two middle values. So right here, between 15 and 16, I'm going to take the average. So 15 plus 16 divided by 2 will be 15.5. So my median will be 15.5. Now, to calculate the interquartile range, I'm going to have to find the middle of the data set to the left of the median and the middle of the data set to the right of the median. So let's look on the left. It appears that the middle is right here between 9 and 11 because there's 6 values, which is an even number. I'm going to have to figure out what the middle is. So I'm going to take the average of 9 plus 11 and divide that by 2 to get 10. For the right side of the data set, I also have 6 values, so I need to find the middle, which will be here between 17 and 18. I'll take the average of 17 and 18, and that will be 17.5. For the interquartile range, I will need to take the differences between the 17.5 and the 10 to get 7.5. Next, we're going to talk about some test-taking tips. So here are some test-taking tips for how to succeed on the FSA. The first thing you want to do is practice, practice, practice. Go back over your homeworks. Utilize school resources to practice math problems in areas that you were weak in. Take advantage of your tutoring and support services at your school, and when you're there, practice your math problems. For the night of the assessment, before, you want to get a really good night's sleep. And then when you get up, eat a well-balanced breakfast the day of your test. You're going to be given a yellow folder for scratch paper. And so what you want to do is, if you are working some problems and you're unsure about the problem, you want to flag it, write it down at the top of your yellow folder to come back to review. When you're working these problems in this folder, you want to keep your work organized. You don't want to scatter your problems all over the place, because when you go back to look at these flagged problems, you want to make sure that you can find them again and not have to start all over. Don't overthink your problems. Go with your gut on this assessment. Your mind is trying to tell you what the correct answer is. Check your answers by making sure that they're valid. Substitute them back in if you can, but go with your gut. You're going to do terrific. So there are many resources available for you for your FSA. At fsassessments.org, you can find these resources, such as practice tests. You can look at the technology enhanced items, the equation editor tool. You can look at the timing. All of these are available at this site. Great site to go to. When you click on the Resources tab at fsassessments.org, you can find some really great tools here. We have the equation editor tool. This is where you will go in and practice actually putting in equations using their keyboard, their on-screen keypad, learning how to put in your exponents. It's a really good tutorial. You need to go through this. It doesn't take long, but it will benefit you a lot. There's also practice with the FSA scientific calculator, and you will find your reference sheets. I want to thank you for viewing this Algebra 1 review. I hope you were able to get some great information from this session, and wishing you the greatest of success on your FSA. Good luck!